This lesson on drag racing is just a fun way of practicing on our equations. We're going to look at a YouTube video of a race between a Ferrari and a slightly modified smart car. Here it is. And so there's the results. The little smart car, I guess they replaced its engine with a racing motorcycle engine, something like that. It came in at a 400-meter finish line with 13.29 seconds. The Ferrari was 13.4 seconds. Now, when we analyze this race, we're going to assume that the cars had constant acceleration, but that's not really what happened. But we need to make some assumptions to make things a little bit easier so that we can handle it with our current equations. Otherwise, we need to do much more complicated equations, and that would not be a good idea. So anyway, here we go. Question number 1. According to the last portion of the video, what was the final displacement of the Ferrari? It was a 400-meter race. According to the last portion, what was the elapsed time? 13.4 seconds. Okay, now from that information, we can figure out the average velocity of the Ferrari. What would be the equation that would tell us average velocity with the known information? Check out the equation list, and here it is. Yep, it's a simple little equation that we had from lesson 1. So put in the numbers, and we get 29.9 meters per second. That's about 75 miles an hour. That's just the average velocity, not the fastest. So the final velocity of the Ferrari, what would that be? Well, we know this information. We also know another piece. Actually, we know a couple more. Can you think of the one that's going to be important here? It was that the initial velocity was 0. Now, we are trying to find what variable? We're trying to find v sub f. So look at your equation list. What equation has vf and at least some of these other numbers? We may not use all of them. This one would work. There's actually a couple other equations that might give us the right answer as well. It doesn't matter which one you use, you'll get the same answer. Okay, so let's put in our numbers. The delta x is 400. We're looking for the VF. The initial velocity is 0, and the time is 13.9. And you get 59.8 meters per second for the final velocity. So that was, about 140 miles an hour. There is another way of looking at this problem that is more conceptual and less using equations. Let's start off with the idea that our initial velocity is 0, and our average is 29.9 meters per second. And the average is somewhere between the 0 and some higher number, which is the final velocity. Now, the average, remember, is the midpoint. And so that means that the change in velocity that occurred in the first half is going to be the exact same as the change in velocity during the second half. It just keeps on getting faster and faster. And so if the first half had a change of 29.9, the second half is going to have a change of 29.9. So what number is 29.9 bigger than 29.9? And the answer is 58.9. What was the acceleration of the Ferrari? Once again, this is the information that we know. Displacement, average velocity, the initial and final velocities, and the time. We want to find the acceleration. So look at your equation list. What equation has A and at least some of these other things? We don't have to use all of them. And this one will work. So the VF is 59.8, VI is 0, we're looking for the A, and the T is 13.4. So all you have to do is divide both sides, and we get 4.4 meters per second squared. And that's the end.